Alright, in this video I'm going to be working Algebra 2 Homework 12.3. And so we're going to need a calculator for this one. Let's see. And of course my calculators are locked up. And the first one is going to be a half-life situation where Q is a mass whose half-life is 1,620 years. Okay, so they even give us the formula. So we're going to determine the initial quality at 0 years. So that would be the value of Q where T equals 0. So Q of 0 equals 16 times 0.5 to the 0 power. And 0.5 to the 0 power is going to be 1, and so that's going to be 16. Okay, we could have also just looked at that number that's attached on the outside, that's multiplied by the half, that's going to be the starting value. Determine the quantity present in 2,000 years. Okay, so that'll be Q of 2,000 is going to equal 16 times 0.5 to the 2,000 divided by 1,620. Okay, we get 6.799, or 6.8. We don't have units, so we're just going to say 6.8. All right, a radioactive isotope has a half-life of 13 hours. Okay, so the amount is going to be equal to some starting amount. That's 400 milligrams times 1/2 to the T over H, where H is going to be 13 hours. Okay, after 52 hours, that would be the amount left at time T equals 52. That'll be 400 times 1/2 to the 52 divided by 13. Wait, I know how to do 52 divided by 13. That's going to be 4. Okay. And 1/2 to the 4 is 1/16. So this would be 400 divided by 16, or 25. I should have done that. Okay. Then let Q represent the mass of radioactive radium in grams. We've got a half-life, and they just gave us formula. So initial quantity after 3,000. Okay. Q of 0 is going to equal 25 for reasons that we saw in 1a. If we plug in T equals 0, we'll just be taking 25 times 1. After 3,000 years, I'm going to have 25 times 1/2 to the 3,000 over 1599. Okay, 25 times 1/2 to the power of 3,000 divided by 1,599. I get 6.810 milligrams. No, grams. Radioactive isotope has a half-life of 13 hours. We already did this one, so we're not going to do it again. Okay, half-lives range from less than a second to billions of years. That's true. It's science. Table below shows the half-life of several substances. Select the best answer. All right, how many grams of a 500-gram sample of this substance is left after 2 days? All right, so I need scrap paper. So if the sample is 500 grams, that's the starting amount, and A is going to equal 500 times 1/2 to the T over, we have to look this substance up, that's 6 hours, so T over 6, where T is measured in hours. And after 2 days, okay, we need to convert that to hours, that'd be 48 hours. So A is 500 times 1/2 to the 48 over 6. 48 divided by 6 would be 8, so 1.953, and that would be answer choice A. Okay, number 6, which equation can be used to find how much of a 50-gram sample of nitrogen-16 is left after 7 minutes? Okay, well, it's T divided by H, so 7 divided by the half-life is 7, so I'm going to be taking it to the first power. Okay, so it's going to be F. Don't need to write anything for that one. 37. How many billions of years will it take 1,000 grams of uranium-238 to decay to just 125 grams? Right, well, uranium-238, that's the 4.5 billion years. So A equals 1,000 times 1/2 to the t over 4.5, where t is measured in billions of years. And if we want to have 125 equaling that, see, 125 divided by 1,000 is 1/8. Now you could solve this one by graphing and like finding the intersection on a calculator, but I know that this one is doable by hand. Okay, so 1/8 is 1/2 to the 3rd power. So I need t over 4.5 to equal 3. So t is going to be 3 times 4.5, so that would be 12 plus 1.5 is going to be 13.5. Researcher had 37.5 grams left from a 600-gram sample of sulfur 35. That's misspelling there, I think. Yeah. How many half-lives passed during that time? So I'm going to start by writing a formula to figure out how many half-lives passed. I don't really know what else to do, so amount is going to be 600 grams sample times 1/2 to the t over, if it's sulfur 35, 87. And then we only have 37.5 grams left. And maybe I divide 37.5 by 600. Maybe there's something I'm supposed to see here. Okay, maybe we'll take that to a fraction and see. Yeah, that's 1/16. Okay. So that means, really, I've taken 1/16 equals 1/2 to the t over 87. But t over 87 is like the number of times I've multiplied by 1/2. So it's the number of half-lives. So I know that t over 87 needs to equal 4, because 1/16 is 1/2 to the 4th. So I know it's going to be 4 half-lives. And then look at problem 8. How many days passed during that time? Well, 4 half-lives would be 4 times 87. And 4 times 87 feels like a little bit bigger than 320. Yeah, by 28. And that's going to be 340. So we've got a chemical called bismuth. Has a half-life of approximately 20 minutes. Find the amount of bismuth left from a 30-gram sample after 2 hours. All right, so 2 hours, if we need to convert that to, minutes, to remind you, I know a lot of y'all are in chemistry, so you're very familiar with this right now. We're going to multiply by a clever form of 1. 1 hour is equal to 60 minutes. So like if I divided them by each other, it would be multiplied by 1. And so that would be 120, cancel the units, minutes. And so amount is the starting amount times 1/2 to the t over the half-life, which is 20 minutes. And so if I plug in 120, that would end up being 6 half-lives, or we could just say A of 120 equals 30 times 1/2 to the 120 over 20. And then we'd have, okay, well, that's something I'd probably drop to the calculator. 30 times 0.5 to the power of 6, and, provided that you're brave enough and believe in PEMDAS, you can type it in like that. And that'd be 0.46875. Grams. Okay, and looks like that's all of the half-life problems. So we'll move on and do a little bit of compound interest. All right, so the first one is Holden deposited $2,250 into an account that pays 6% annual interest compounded monthly. Okay, there's a lot in there. So in the formula that we need to be working with, probably be good for me to write it up here, is the amount of money in the account at time t years is equal to the principal, the starting amount, times 1 plus the interest rate divided by n to the nt, where n is the number of compounding periods per year, the number of times per year interest is added. So it would be, if it's monthly, n equals 12. So I'm going to kind of just, write in my parameters, 2250, 6% annual interest. So R is 6% is 6 divided by 100. Compounded monthly is n equals 12. So I can write my formula. A of t is going to be 2250 times 1 plus 0.06 over 12 to the 12t. If we want to find the balance after 10 years, that would be A of 12 is 2250 times 1 plus 0.06 divided by 12 to the 12 times 10 is 120. This is definitely a job for the calculator. So I'm going to go over here and grab that calculator. And if you got the fraction bar, you should type it in just like you see it. Then we get $4,093.64. Okay, simple interest, we don't really need to worry about that because it's not exponential. So I'm just going to go ahead and skip number 2 and say that's not something you need to worry about in this class. That's something you can do in a finance class or in Math 6 or whenever that is supposed to hit, but not Algebra 2. Madison deposited $1,000 into an account that pays annual interest compounded quarterly. Okay, so 1,000 times 1 plus R, 0.075, divided by n, the number of times per year that interest is added. Quarterly would be 4 times per year, to the 4t. And so I'm going to plug in 5 here. A of 5 is going to equal 1,000 times this to the 4 times 5, which is 20. Okay. Let that happen. To the 20th power, I get $1,449.95. Okay. Borrowed $2,000 at simple interest rate. Okay, again, simple interest, we don't need to worry about that. Was the total amount of interest that was added to the principal after the 5-year period? Yeah, okay, that's a more interesting question. 28,000 times 1 plus 0.04 compounded annually, that means once per year. So the 1 times t to the power of 1 times t. And after 5 years, we'll find the total amount, and then we'll have to subtract away the 28,000 to figure out, what of that was interest and what of that was principal. Times 1 plus 0.04, so that'll be 1.04, to the power of t, which is just going to be 5. And then we get $34,066. But if we just want to know the amount of interest that was added, then we would subtract away the 28,000, and we would get, okay, so I'd say A of 5 equals 34,066.28. As a result, the interest that was added is going to be $6,066.28. Okay. This is just going to be more of the same. Okay, with this, make sure we get the formula right and then plug in the right value of t. I'm going to do, we don't need to do this 8 times. I'll do this one more time and I'm going to call it for this video. So $20,000 and compound, and that's monthly. Let me see if there's anything different between monthly, annually, monthly, quarterly. Okay, I'll do this one. $35,000 times 1 plus 0.06 divided by 12. I think we did one very similar to this. To the 12t would be 120. It's going to be and we get 63,678.89. And now if we wanted to figure out when the value of this, went over 60,000, what we could do is we could go and, like do a little intersection on the calculator. And I see that this homework isn't really requesting it, but that's something that you will be, seeing on the review, seeing on the test, that type of thing. Okay, so that's going to be all for this one, because this is just getting really repetitive, and I think this is enough practice for all of us for now. That's it. Thanks for watching.